It's recording now. Okay. The thing I want to explain about the graph is the graph of the another trigonometric function because we emphasize sine and cosine. I promise that today I go over again to the sine and cosine, but I want to explain tangent, secant, cosecant, and cotangent, right? It's not extremely important. Do you see what is important, Professor? The important is the graphic you see in the package, in the review package. But no, I need to cover everything. If you want to focus, see, and the important is the graphic you see in the review package. Okay? Okay, by the way, I sent today, no? Everyone saw that or no?
Yes.
Okay. Now, let's do in the graph of the tangent. But quickly, okay. Look, tangent. Suppose y equal tangent without transformation. I know by memory. Que tangent 0 degree is 0. The point is 0,0. I know by memory que tangent 45 degree is 1. The point is 45, que is pi over 4. Normally, the graph is doing in radians, not in degree, but it doesn't matter. You can do in both ways. This is x-axis. I suppose that this point is the point 0, 0, this is pi over 4, 1. 1 here, this point. And tangent 90 degree is undefined. So no value. The reason que pi over 2, que I suppose que here, is asymptote. It's a vertical asymptote. Look, let me show you. So the graphic of the tangent look like that. It's approaching to positive infinity. In the other direction, so where the next guy? The next guy is pi, or 3 pi over 2, sorry, and pi, no? The graph is similar, like that. We have another asymptote here. Wait. This is pi over 2, 3 pi over 2. No, pi this. I make a mistake. This is pi, obviously. This is pi, and this is 3 pi over 2. So we have another asymptote here. Because 3 pi over 2 tangent is also undefined, and tangent pi is 0, tan 180 degree is 0, and the graph of the tangent look like that. Here. Okay, it's a curve. It's a curve. Thus now I can see clear. Okay, the tangent function, the period is pi. Entonces remember, you need to do only one period. Entonces, the period I recommend to do in any graph of the tangent is that period. Look. We have negative pi over 4, and we have negative pi over 2. And here we have another asymptote. Okay, you see this curve, by the way, in negative pi over 4 is negative 1, totally symmetric, so it's odd function. This is negative infinity. So this is one period. Okay, you have the famous 5 point. Okay, actually it's not 5 point, it's asymptote, point, and asymptote. And the rest is repetition forever. Let me explain. I want to move to the Desmos to see more clear. And after I want to explain using Desmos, cosecant, secant, and cotangent. Okay, so I try to switch into Desmos. I have here Desmos. Okay. Desmos now. Here. Do you see Desmos? Do you see Desmos?
Yes.
Super. Okay, look at that. This is the famous curve of the tangent. Okay. In negative pi over 2, we have one vertical asymptote. The point is, this point is negative pi over 4, comma negative 1, 0, 0, and pi over 4, 1, and in pi over 2 positive, another asymptote. Look, this is the asymptote. Another asymptote. And the tangent, this is one period of the tangent. Okay, by the way, the width of the period is pi. Remember, in cosine and sine is 2 pi. In tangent and cotangent is pi, the period. This is the graph of the completed tangent in different period. Pero remember, in the test, you only do the graph of the one period. Do you understand the idea? I promise in the review packet we go over again to this. You understand the basic idea? Yes or no? Yes or no? No. All right, what part no?
So, Professor, I didn't understand how we found like the period, because you told like the period we calculated is divided by 2.
No,
Right?
no. No, the periods always divided. Okay, you need to know by memory que sine and cosine and cosecant and cotangent, the period is 2 pi. O sea, it's periodic functions when the period is equal to pi. However, tangent and cotangent are special, and the period is pi. By memory, okay?
Okay.
Okay.
Yes, Professor, I got it.
Okay, now let's move on. For example, this is the cosecant. The cosecant, you know, que es the reciprocal of the sine. So you say, wow. Well, look, let me show you the graph. Boom. Wow, it's weird. Okay, actually, the graph of the cosecant is the blue color. So to do the graph of the cosecant, the only thing you should do is do the graph of the one auxiliary sign. Okay, I put in dotted line. Look, this is the auxiliary sign. Look. Entonces now, when the sign is 1, es obvio que the cosecant is 1. Because 1 over 1 is 1, no? And when the sign is 0, the reciprocal 0 is undefined. That is the reason it's vertical asymptote. Now you have the famous 5 point, the period is 2 pi, 0, but in this case 0, comma undefined, pi over 2, comma 1, pi, comma undefined, 3 pi over 2, comma negative 1, and 2 pi undefined again. So it's super easy. So you understand very well. Do the graph of the sine. You can do that easy, the graph of the cosecant. Right? The only thing is, when the amplitude maximum, bueno, entonces dices minimum, pero positive. Okay, entonces when the amplitude is a negative minimum and the sine auxiliary curve, entonces the cosecant is positive, maximum negative. And the secant, wow, it's the same. The secant is the same. The secant is the same, except que the cosecant matching with the cosine. Okay, look, this is the graph of the secant. Well, okay. This is one period, 2 pi, 0 to pi. When it's 1 is 1, when it's 0 undefined, when it's negative 1 is negative 1, and so on. So you want to extending the secant graph is this. Okay, do you understand the idea? It's no big deal. It's super easy. The only graph that you need to learn super strong is sine and cosine. Of course, tangent. The rest is easy. Cotangent is the reciprocal of tangent. This is a typical graph in the one period of the cotangent. Because the tangent is like that. Look. This tangent. And the cotangent is, when the tangent is 0, cotangent is undefined asymptote. When the tangent is undefined, cotangent is 0 because reciprocal of undefined is 0. And when so basically in 0 is undefined, in pi over 4 is 1 because tangent pi over 4 is 1 and reciprocal 1 is 1. And pi over 2 tangent is undefined and the cotangent is 0. In 3 pi over 4, the tangent and cotangent is the same value, -1. And in pi is, this is pi, yeah. Cotangent pi is undefined. But big tangent is 0. So it's relatively easy. Do the graph of another trigonometric function, cosecant, secant, and cotangent, because you know very well how we are doing the graph of the sine, cosine, and tangent. Tangent we discussing a little bit quickly today, but in the review packet we go over again to this. So my proposal is now, let's do it to the review package, but in the graphic part of the review package. Okay, we start in the question 44. Trigonometry, review package. No, carajo. Wait. PDF, review. Sorry. What question? We are doing question. The first question of the graph is this. 44, right? Okay. So we are doing backward. No stuff 1, 2, 3, 4, 5. No, 44. We are doing the graphic part. Because we are familiar, and after, remember, we have 2 days to do this review. Today and the third day. Okay, I suppose we have time. So I want to go, but slow down in detail. Okay, let's move on. Question 44. Do the graph of this. I want to do by hand and after in decimals. To sine. 3x. A is 2. B is 3. We use B always to compute the period. The period is 2 pi over B. In our specific example, is 2 pi over 3. This is the period. And subinterval width is the period divided by 4. It's 2 pi over 3 divided by 4.
Professor, I don't know, but I can see the whiteboard.
You don't. Okay. Now, Noela?
Yes, Professor, now I can see it.
Okay, so we start at the beginning. Erase everything. So we are doing question 44, que is the first question about the graph and the review package, correct? I see que A is 2. Remember, A is amplitude. And B is the parameter que give me information about the period. Period, the formula is 2 pi over B, always. In our specific example, B is 3, that's 2 pi over 3. 2 pi over 3. And subinterval width is the period divided by 4. It's 2 pi over 3 divided by 4. It's 2 pi over 3 times 1 over 4, que is pi over 6. Because divided here by 2 is 1, divided by 2 is 2, 2 times 3 is 6, pi over 6. So that means that our sine, I want to do the graph. So you are doing, for example, the partition of the x-axis. Look, this is my famous x-axis. And remember, the only thing you should do is do the graph of the one period. This is my famous x-axis. Yeah, I know very well que the sine starts in 0. And my first point is 0. And my last point and the period is 2 pi over 3. So we have the famous 5 point. Look, 1, 2, 3, 4, 5. And the step is pi over 6. Pi over 6 is the first. Subinterval width is that distance. Okay, now pi over 6 plus another pi over 6 is pi over 3, no? Pi over 3. This is pi over 3. And pi over 3 plus another pi over 6. This common denominator is 6 is 2 pi plus pi is 3 pi over 6, que es pi over 2. It's pi over 2. And I know okay, the last one is 2 pi over 3, but by curiosity, let me check in pi over 2 plus pi over 6. LCD is 6. Entonces 3 pi plus pi. This is 4 pi over 6. And when you reduce the lowest term, 2 pi over 3. Perfect. Confirmation that we are doing well. And the amplitude is 2. And remember, I need to remember only that the sign is coming 0 maximum positive. So this is 0, the first point. The second point is maximum and pi over 6. How many units? 2 units, no? Because the amplitude is 2. 1, 2. Okay, my next point is this point. My next point is this point. Now negative 2. Here, and 0. Wow. And we are doing the graph of the one period in the story. But we are doing now elegant in Desmos. And you forgot that part because nobody understands this.
Professor, I do have a question.
Go ahead.
Professor, the thing that I don't understand in this graph is how we find like the values of y.
Well, the value of y is you need to determine only, Nuela, this point, this point, this point, this point, and this point. And this point is 0. The y value is 0. The y value here is 2. So this point is the point pi over 6, 2. This point is the point pi over 3, 0. And this point is the pi over 2, negative 2. And this is the amplitude, que es 2. And this is 2 pi over 3, 0. Do you see that? Noela?
Yes, Professor, but the thing is, I didn't understand why we have like the 2 as a y.
Because you need to know call algebra, one function, and when you multiply by 2, these 2 outside affect is like a vertical stretch, 2 units, the factor 2. You need to know by memory that the basis sign, the amplitude is 1 and negative 1. So amplitude is 1. So you have 2 in the front, so your new amplitude is 2. This is clear?
Okay, I got it. Thank you, Professor.
Sure? Okay. Okay, let's go to Desmos.
Professor, before we go, can I take a picture?
But after, take a picture of the elegant. The elegant. No, this is rough freak. I did by hand. No, this is crazy. Look, Noela. Okay, let me switch into another. Is this one? Review. Okay, question 44. Look, I did the graph in Desmos. Look here. And the graph look like that. Noela, look at that. Take a picture now.
Okay, thank you, Professor.
Okay, guys. Let me explain step by step because it's the same routine. You determine period. And you determine subinterval width, in this case pi over 6. And from 0, because I know by memory also that the graph of the sign starts in 0, 0. The graph of the sign is 0, positive 2, 0 again, negative 2, and 0 again. And of course, you are doing the graph of the one period, but also you want to extend it in both directions. Look, this is the graph of the hour. It's repetition to the right and to the left. Pero no. Sorry, in the test, you are doing the graph of the one period only. Beautiful. Any question? Come on, it's a moment. This is easy. This is no big deal. So you need to learn.
No questions, Professor.
Okay, let's move on to 45 now. 45, and you help me. Okay, I switch it whiteboard, I switch it decimal. I ask you, you see decimal, you see whiteboard.
Decimal.
Now whiteboard. Okay. Do you see whiteboard?
Yes.
Okay. The
No,
next.
yes,
No?
yes.
No. Okay. The next question is 45, no? Let me try to put in the whiteboard. 45, 45, 45 is this question. Look at that. Do the graph of this. This option, okay, the test is no multiple choice. So this is a package, but you don't care that part. This is crazy. I never realized what the option is correct. But it's not important. The important is you focus on the equation. We are doing the graph by hand. Check it out in decimals. And the test on paper, you send me the image when you download in decimal. 3 sine 1/2 x. Okay. I saw A es 3, que es the amplitud. Correct?
Yes.
That means que our sign oscillated in between positive 3 and negative 3. Correct?
Correct.
We have period or B is 1/2. B is 1/2. Therefore, period, que the formula is 2 pi over B is 2 pi over 1/2. Entonces, 2 pi, and you reciprocal the flip that is 2, no? 2 over 1, no? Flip that is 4 pi. The period is 4 pi. And the subinterval width is pi divided by 4. Is pi. Very well. 4 pi divided by 4 is pi. Therefore, the partition of the all real number line is we start at 0. We ending in 4 pi, que es the period. Divided by 2, divided by 2, divided by 2, because the interval is the same. This is pi. This is 2 pi. This is 3 pi. And this is 4 pi. And the amplitude is 3. 1, 2, 3. 1, 2, 3. My graph will look like that. 0, 0, maximum, minimum, minimum no 0, sorry. Minimum is negative 3. And this is this. Okay, I am doing no good. The graph of the sine and cosine is a smooth curve like that, not like that. Okay? Entonces I have roughly idea how it look like. Excellent. No question. Guys, I am doing well or no?
Yes, Professor. So it means, Professor, he has a pattern, right? He's always like starts with 0, 0, and then it goes like to the amplitude, and then it goes down. Like I'm noticing the pattern.
Yeah, see, we have reflection or phase shift, que is the complicated part. Let's see. But let me understand one by one, Noela. Okay? You don't try to understand everything in one example. Okay? This is classical. The only information that you have A and B, no more information, A and B. Okay, let's move on to decimal to see elegant. Entonces, en decimos, here. Okay, question 45. Ooh, question 45. Okay, do you see? Is that sign 0, 3, 0, negative 3, 0. One period. You want to see several periods? Bang. Let me use in, yeah, it's okay. One period. It's the thing I want. Do you understand very well this or no? Clear no, or no?
It's clear.
Good. Okay. Let's move on again to the whiteboard. Do you see whiteboard now? Yes or no?
Yes.
Okay. Question 46. 46. Now. 46. Okay. 46 is y equal minus 3 cosine x. Okay, when we have amplitude 3, is 3. But we have reflection. How do you know? Reflection is obvious que es on the x-axis. Because this -1 in the front indicates reflection. So actually, I know by memory that our cosine start in positive maximum, but in this case, no, because we have reflection. So we start in negative minimum. And the B is 1. No transformation in that part. Therefore, the period is 2 pi over 1 is 2 pi. And the subinterval width is pi over 2. Because 2 pi divided by 4, no? 2 pi divided by 4 is pi over 2. Okay, so let's do it quickly. The partition of the x-axis is, look, x-axis. Okay, this is 0 again. The period to pi. Half, half. Each step is pi over 2. Pi, 3 pi over 2, and 2 pi. So this width is pi over 2 plus pi over 2 plus pi over 2 plus pi over 2. 5.1, 2, 3, 4, and 5 point. It's the only information that you need. The amplitude is 3, but I know que our cosine start en máximo 3, pero es reflection, entonces es negative 3. Entonces es negative 3, like that. Look. -1, -2, -3 here. This is my first point. This is my second point. This is my third point, que es en positive 3. This is 0 again, and this is -3. And we complete one period. This is the graph que corresponde with the question 46, no? Que is the -3 cosine x. Just in case, let me check it in Desmos. This answer. Do you follow me? It's okay, Noela?
Yes, Professor.
Okay, the only thing you need to remember is sine está en 0. Cosine está en máximo. Si we have reflection, then, sorry, a little bit. I'm back. In this case, it's cosine. Cosine start in maximum, but in this case, it's minimum because it's negative reflection. Let's move on to the decimal to see more clear. Okay. Switching to decimals. Here. Okay. Decimals. 46 problem, no? 46 is something like that. Look. Oh, look at that. 46 is negative cosine. It's a 1 period, 2 pi is a period, therefore we extend it in both directions, several periods. This is the famous 5 point. 0, -1, pi over 2, 0, pi, 1, 3 pi over 2, 0, and 2 pi, -1, because it's reflection. Okay, clear or confusing?
So, Professor, when we have a reflection, it starts on the negative side, right? There is always something like 0, -1.
Okay. It's exactly the same you see in color algebra. When you have two kinds of reflection. You have two kinds of reflection. Let me go to the whiteboard. You have two kinds of reflection. You have reflection when you put negative sign, no? But you have two possibilities to put the negative sign. In the function notation, you, for example, you put any function, and you put a negative here. This is a reflection about the x-axis. So my original cosine, I know, look like that. Okay, this is cosine without negative, just cosine, y equal cosine. 3 cosine. Of course, 3 amplitude is not the thing we are discussing now. Amplitude affects this distance. Si es 3, si es 4, si es 5. But the reflection change completely the sign, point by point. Si the point is negative, now this point is positive. Make sense? Make sense? Okay. So let's move on to the next question. 47, no? Yes or no?
Yes.
Okay, 47 is different because it's tangent. It's tangent. It's tangent. Entonces tangent, let's see what the procedure for the tangent. 47, this tangent. 47, all right, let me see. Yes, 47. We are doing the graph of the y equal 3 tangent x. Entonces now, A es 3, es obvio. And B is 1. Because we have no coefficients here. But the formula is different. Period is pi, not 2 pi, pi, because the period of the tangent is pi over b. In our specific example, b is 1, so the period is pi, just pi. And the subinterval width is period divided by 4, is pi over 4. But the partition that we are doing is different. Well, it's different, no. Is, look, let me show you. In the case of the tangent, okay, we are doing here all real number line. But you start not in 0. We start in pi over 2 negative. So this is look here. This is 0. And we have the famous 5 point. And the famous 5 point, you start here in negative pi over 2. We have here now pi over 4 negative, because the interval is pi over 4. So negative pi over 2 plus pi over 4 is negative pi over 4. Negative pi over 4 plus pi over 4 is 0. 0 plus pi over 4 is pi over 4. And pi over 4 plus pi over 4 is pi over 2. Yeah, I know that in pi over 2, we have two vertical asymptotes. Because in pi over 2, the tangent is undefined. Y I know que tangent 0 es 0. Y I know que tangent pi over 4, que es 45 degrees, es 1. So that point is 1. and here is -1 because it's in the fourth quarter. Entonces, the graph of the tangent is 5 points, pero 2 points are two vertical asymptotes. Approximately like that. Here. Like that. And you see elegant in decimals now. Okay, to say it's different, it's vertical asymptote 1, the point is -1 because we have no reflection. Another point is, I know que tangent pi over 4 is 1. And pi over 2 is undefined. Tangent pi over 2 is undefined. That is the reason this asymptote. It's a y-axis. Entonces, to do the graph of the tangent, we need 2 vertical asymptotes and 3 points. 1, 2, 3. 0, pi over 4 positive, and pi over 4 negative. I make a mistake. And amplitude is 3, no 1. Entonces, we have 3 here. Look. Here. 1, 2, this is 3. This is 1, 2, this is -3. Because the amplitude is 3. Así es the tangent, the basic tangent, when the A is 1, no transformation, entonces now it's 1, but in this case 3. And the graph look like that. Do you understand this or no?
I'm
okay,
just
let me repeat, repetition. Tangent is different. Because tangent have asymptote. And you need to do the graph of the one period in between two asymptotes. It doesn't matter which one, but I prefer from negative pi over 2 to positive pi over 2. Because the period is pi in this case. In other case, no. In other case, it's different. You take the period, que is from negative pi over 2 and positive pi over 2, in total 1 pi, and you divide by 4, because we have 4 pieces and 5 points. And the 5 points is the 3 classical points plus 2 asymptotes. And the amplitude is 3. Therefore, in pi over 4, because actually, see, we have 1, 3 here in our equation, the answer is 3, no? No 1. Makes sense?
It does.
Okay.
Mark, can I ask you a question, Professor? Hey, Professor, how we calculate the asymptotes? I forgot.
Well, asymptote is when the function is undefined. They are in Collet algebra. We have, for example, one function to be undefined. When you, for example, the value here is a whole, the whole is something like that, or asymptote, vertical asymptote. Because the function, for example, the function, not trigonometric function, f of x equal 1 over x. 1 over 0 is undefined, no? I know that function have vertical asymptote here at 0. That function look like that. It's similar asymptote. Asymptote is that the curve approaches to the vertical line but never touch. Let's see in this one, Noela. Let's see. Okay. Here, over there. Okay, look at that. 47. We are doing 47. Wow, 47. It look like that. However, I did in the decimals 1 period, but 1 period different. Okay. Don't worry, be happy. Look. Because I did 1 period between 0 and pi. However, let me change. For example, negative pi over 2, negative pi over 2, 2 pi over 2, over 2. And we have another asymptote here at x equal negative pi over 2. Remember the asymptote always black color, dotted line. Boom. And the point, I want to change the point. This is good, but it's another period. Remember, you are doing, what is the classical period you are doing always is in between negative pi over 2 and positive pi over 2. We can do another period. When I do the demo the first time, I do like that, but oh, no. This is much better. This is negative pi over 4, negative pi over 4, negative pi over 4, comma negative 3, and that's it. And that's it. This no 3, oh, this is black color. Black color. We have the asymptote and pi over 2 negative, pi over 2 positive, pi over 4 negative 3, 0,0, and pi over 4,3. Because the amplitude of this is 3. Do you follow me?
Yes,
okay.
Professor.
I fixed that. Okay, now let's move on to the next problem. It's easy. When you get the mechanical of this, it's easy. Okay, let me change to the whiteboard again. Whiteboard. Okay. Erase everything. Okay. Now let's move on to the next, the 48 question. I suppose que es this, 48. Boom. 48, guys. 48 is y equal 3 times, the amplitude is 3 again, tangent 1/2 x. In this example, a is 3. Okay, good. But b is 1/2. So when you compute the period is pi. Remember, it's pi en tangent and cotangent. En sine and cosine is 2 pi. Pero en tangent is pi. Divided by 1/2. Okay, entonces you flip that, es 2 pi. And sub interval width is period divided by 4. Entonces 2 pi divided by 4 es pi over 2. Pi over 2. Pi over 2. Now, when you are doing the partition of the x-axis in our graph, the period is 2 pi. Look, this is x-axis partition. I know that the graph of the tangent contains 2 asymptotes. One here, another here. And this is completely symmetric because it's odd function. So this is the entire period gets 2 pi. I suppose that distance is pi and this distance is negative pi. And here, pi over 2. So we get negative pi over 2. Here, plus pi over 2 is 0. Plus pi over 2 is pi over 2. Okay, no reflection. So it's the same. So in 0 is 0, definitely. And pi over 2 negative is negative 3. 1, 2, 3. And pi over 2 positive is positive 3. 1, 2, 3. Okay, our graph looks like that. Okay, remember the asymptote, the curve approaches but never touch the very cast. So this line continues forever but never touch. This is the graph. Do you see or no? Beautiful. 48, no? 48. Do you see or no?
Yes, Professor.
Let's see in decimals to see
But
more.
this idea is still complicated a little bit, Professor, to me. I don't know.
No. I don't know complicate. I always explain in the super easy way. This is my fundamental characteristic. Complicated thing, Calculus 3, I explain for everyone, and everyone understand. This is the easy way, Noela.
Yes, Professor.
What part you see complicated?
The part that is making like the things complicated, Professor, to me now is the isotope.
Okay, no, but this is a process, practice. You practice. It's the first time you see in your life, no?
It is, Professor.
Okay. I understand. Let's move on to Desmos to see more clear. Desmos. You see Desmos now or no? No, not yet.
No, just like the whiteboard.
Whiteboard. Now?
Yes.
Okay, we're doing example 48, no? 48 is this. Look. Ooh. I fixed that. Okay, I did in another period que es not good. Okay, entonces es en between negative pi, and positive pi. Excellent. And the asymptote es en pi over 2, no, en pi and negative pi. Okay, make another here asymptote at x equal negative pi. Oh, no. Black color. Dotted line. Red or black, no, purple color. Okay. It's a pi and negative pi. And the point is, okay, this is negative pi over 2. Negative pi over 2, comma negative 3 is excellent. And this delete. It's the same. Because the thing I did before was do the graph of the next period. You know, this is several periods. Look. But I did the graph of the only one period. It's enough because the rest is repetition. So basically, guys, tangent contain 3 points and 2 asymptotes. Okay? And you determine the period. And the period is the total distance between 2 asymptotes. And divided by 2 is the distance in between 0 and 1 asymptote and 0 of another asymptote. Okay? And 0,0 is classical point in the tangent. Always. Okay? Oh, sorry. This belongs to this. Now 49. 49, 50, 52. Okay, 49. 49 is, let's move on again to Desmos. To the whiteboard, sorry. Whiteboard. I am in whiteboard?
Yes, you are.
Okay. Question 49. Now. 49. Is this, I guess so. 49. There you go. Okay, es y equal negative 2 cosine 1/3 x. Ooh, look at that. A is 2. Amplitude. We have reflection because it's negative. B is 1/3. Therefore, the period is 2 pi over b. Okay, 2 pi over 1/3. It's 6 pi. 6 pi. And the subinterval width is 6 pi divided by 4. Okay, when you reduce the lowest term, it's 3 pi over 2. This is classical, right? Yes or no?
It is.
Okay, now the second step after the computation period subinterval width is do the partition of my x-axis. Okay, I don't know, I don't like the negative part. We start in 0, 0, 0, and 6 pi. Divided by 2, divided by 2, divided by 2, and this is our famous 5 point. And the subinterval width is that distance. Que is 3 pi over 2. And 3 pi over 2 plus 3 pi over 2 is 3 pi. Because 3 pi over 2 is 1.5. Plus 1.5 is 3, right? And 3 pi plus 1.5 again is 4 pi over 4.5 pi, is 9 pi over 2. And this plus 3 pi over 2 again is 6 pi. And we had our famous 1, 2, 3, 4, and 5 pi. Do you understand where I come from this fraction or no?
Yes.
Yes. Good. So we are talking about cosine, but you have reflection. That means that our cosine starts negative minimum. Yes or no? Here, negative 2. 0, positive 2. 0 again, and negative 2. And complete one period. Our graph, roughly look like that. Make sense?
It does. So when he's Professor, sorry, can I ask you a question? When he's in cosine, we always start with the maximum, right, Professor?
Yeah. See, we have, for example, Nuela, this negative, positive here. Our graph look like that. Right?
Yes.
And the name of this effect is called reflection. So I keep in my mind, not all 100% possibility. I keep in mind that always any cosine start here. This is cosine positive. And cosine negative is reflection, is the red one. Yeah, I know that my sign is like that. Start in 0. And negative sign is, let me using another color, like that. Correct?
So it starts in negative 2 because it's like the reflection, right, Professor? Okay. Okay, I understood now. I understood.
No, so far. Now, let's move on to the complicated part. When you have phase shift. When you have phase shift, it's very, very, very complicated. Not very, but it's a little bit complicated. May I erase the board? Oh, no. Let's see this graph, in decimal. Oh, no. Not necessary.
I don't think it's necessary, Professor.
But I try. Okay. Okay, 49, no? Look at that. Make a zoom to see more clear. This is cosine, and every direction is like that. Okay, let me move into 50, 51, and 52, que is the phase shift cases. Okay. Okay, delete everything. 59. 59. 59. This is 50. 50 is, wow, it's weird. Is y equal 2 sine 4 pi x minus 3. Entonces identify que amplitud es 2. B es 4 pi. Because B is solved with the coefficient C. This is A sine bx plus C. Voy a incluir C, que es negative 3. Que es the phase shift. Now the phase shift, you are doing different, a little bit different. Look. You are doing like that. Let me show you. You take the expression inside the parentheses, que es this. And you write 4 pi x minus 3, always in between 0 and 2 pi. It's actually one period of the common sign. And you solving this compound inequality, adding 3, this is 3 less than or equal 4 pi x, this is cancel, this is 2 pi plus 3. And finally divided by 4 pi, because my goal is isolate x. This is 3 over 4 pi, x is in between this number and this number. And for a moment, stop. I forgot to say the period. What about the period? The period is p is equal to pi, because it's sine, divided by b, okay, 4 pi. Well, it's 1/2. The period 1/2. And the subinterval width is the period divided by 4, okay, it's 1/8. Entonces, what is the idea? Look, important moment now. Phase shift. When you have phase shift, we have translation, we have horizontal shift. In this case, is to the right, because 3 is negative. This is phase shift. So when you are doing this graph, look, let me show you. Pay attention now. The first point is knowing 0. This noise. Who have to open the microphone? Hello, this is important, hard, complicated part, and you make a noise, coño. This is 0, but no is 0. We start in one number, que is 3 over 4 pi. You don't care, you put in the calculator, it's decimal point. And the last point is 2 pi plus 3 over 4 pi. This is one period. Divided by 2, divided by 2, divided by 2. How you find that value? Easy. You take this 3 over 4 pi plus the subinterval width is 1/8. You compute this in your calculator either way. What is the next? The next is 3 over 4 pi again plus 2/8. Or 1/4. So this is 1, this is 2, this is 3. And this guy is 3 over 4 pi plus 3/8. And the last one is 4/8, get 1/2, no? And you get this 0. This is a maximum. What is the amplitude? 2. 1, 2. This is 0 again. This is -2 now. And this value. And this is 0. Okay? Okay, and you expect one sine function que contain phase shift. What is the phase shift? Phase shift is that distance. Look, the distance between 0 and the first point actually is not 0. When you have no phase shift, they are perfect coincident between this first point and 0. Pero this is phase shift. Phase shift. Phase shift. Okay? Entonces now, summarize the idea. Summarize the idea. You compute the period, 2 pi over b. Compute the subinterval width, 1/8. Set out the inequality. The inequality give me the initial point, que es 3 over 4 pi, and the last point, que is 2 pi plus 3 over 4 pi. And in the middle, we have 3 more points. First, last, and 3 more give me the famous 5 points. How you compute the 3 points in the middle? Addition subinterval width several times. 1 time, 2 times, 3 times. If you want, you put this in your calculator and compute in decimal. Pero no, I don't want to do it that way. No, No, how? Why don't you put in decimals? Look at that. Let me show you. You go to decimals. Okay. In decimals. Okay, I lost here. That's right. You see decimal? 50. Problem 50. Look. Wow, too small. But that's the answer. Look. And this decimal corresponds with that weird number. Can we put in the whiteboard? Okay, how do you know that? You don't need to do that. Okay. Look, let me set out in the whiteboard and the in decimals. Look. I put 2, I put the function, this is the first point, this is the last point, get the result. This is the result of the inequality. And this is the point, okay? Only I set out like that, 3 pi over 4, comma 0, 3 pi over 4 pi plus 1 over 8, comma 2 is this point, and so. Do you see or no? Do you see or no?
Yes, Professor.
Excellent. So you see this is the most complicated example. I put 50, the most complicated. 51, 52 is super easy. But today I want to finish the graphic part because next time lecture, we cover the rest of the review package. Okay.
Okay, Professor, can I ask you a question?
Please go ahead.
Like everything, like, so Professor, the thing that I didn't understand, like in this graph, is like the phase shift is like between 0 and 3 over 4 pi, right, Professor?
Here's my first point.
Okay.
O sea, normally, Nuela, the original sign que have no phase shift, they are perfect coincidence in between the first point and 0. So our sign start in 0, 0. When you have phase shift, it's like you move this sign maybe to the right or to the left, depending the sign of phase shift. In this case, negative, entonces to the right. Si es positive, si I change positive 2, positive 3, or positive something, entonces to the left. Make sense?
Yes, now I remember it wasn't like the college algebra. Like
Absolutely. Okay, the idea of the color algebra was, but let me come back again to the whiteboard. The idea for the color algebra was, look, you have here a function. Okay, and when you are doing this transformation or this transformation, the motion is horizontal shift. This is to the right and this is to the left. In this case, minus Nuela. That is a reason that our famous sign is moving to the right. How many? That quantity, que is the phase shift. 3 over 4 pi. Make sense now?
it does. Thank you, Professor.
Super.
It does.
Super. Let's move into 51 and 52, and I'm happy see we finished both. Get the graphic part. Okay, 52, no? 52, 51. 51. 51. 51 is y equal 3 times sine 3x minus pi. Okay. Well. The order is not important, but okay. I like this order. A is 3, B is 3, and C is negative pi. But I don't care in that way. This is not good way. Much better for me is set out the inequality. You take this expression and you copy 3x minus pi, always in between 0 and 2 pi, is the period, the classical period of the regular sign without transformation. Addition pi, addition pi, addition pi. It's a pi less than 3x less than or equal 3 pi divided by 3 divided by 3 divided by 3. Entonces es pi over 3 less than or equal x less than or equal pi. This is the phase shift.
So why is it like 2?
Say again?
Why is it 2, like Professor, in the first part that you put 0 less than equal 3x minus pi? Why is that 2 there? I didn't understand that 2.
What 2? This 2?
2 pi. No, like above.
Well, I don't understand your question.
Professor, you see that 2 pi that is like at the beginning.
At
you
the
put
beginning?
0.
Is that standard procedure? Oh, excuse me, I'm sorry, Noella. Is the 0, is the 2 pi standard procedure to put like, okay, we got 3x minus pi. We have the 0 on this side and we have the 2 pi on this side. Is that standard?
Okay. Noela, you copy this expression and always you set out the inequality. You put 0 here and 2 pi here. Your question is you don't understand why 2 pi?
Yes.
Well, okay. The reason is clear because I know that the regular sign without transformation, x is in between 0 and 2 pi because 2 pi is a period without phase shift. 0, 2 pi.
Oh, I got it.
Okay, this is the most important. The most important is, look, when you finish this inequality, I can see okay, this guy is a phase shift. So my graph is a sign phase shift. It's a sign, but start not in 0, Nuela. Start in pi over 3. And ending in pi. My graph look like that. Okay? But I don't finish. Let me explain in detail. Wait a second. Let me erase that part. Okay. Now, I forgot the important part, the period. The period is equal to pi over b. And b is 3 in our example. And subinterval width is period divided by 4. Entonces es period divided by 4, 2 pi over 3 divided by 4 is 2 pi over 2L, que es pi over 6. So basically, our graph look like that. Look, let me show you. This is 0. But I don't care it's 0. We have phase shift, I know. This is 0. My first point is in pi over 3. My last point is in pi. We have here midpoint, and midpoint, and subinterval with pi over 6. So that distance is pi over 6, pi over 6, pi over 6, and pi over 6. Now how you find that? Well, adding pi over 6. Entonces es pi over 2, 2 pi over 3, 5 pi over 6, and finally pi. Okay? And the amplitude is 3. The amplitude is 3. 1, 2, 3. 1, 2, 3. We start here in 0, positive maximum, 0, negative minimum, and 0 again. Our graph look like that. This is fantastic, yes or no? This is fantastic, yes or no? Okay, recap. When you solve the problem of the phase shift, by the way, guys, this is a problem I like to put on the test. When you have phase shift, you determine amplitude A, you determine B. B is using for the computer the period, and so interval width, and stop. How do you know when it start the graph? Because my graph, I know, okay, it start not in 0, it start in the phase shift. You set out the inequality, you copy the expression inside the parenthesis sign, you bound it between 0 and 2 pi, you solve the inequality using algebra, elementary kindergarten algebra, and you determine the phase shift, que es pi over 3, and you determine the end of the period, que es pi, divided in 3 in 5 point, the famous 5 point. This is the 1, 2, 3, 4, and 5 point, and we connect it in that way because we have no reflection. What do you think? Beautiful.
Yes.
Excellent. Thank you, sir, for helping me. Okay, let's do a 52 or no? No,
Professor.
we have no time. Time is over.
Fine,
You know,
Professor.
the problem is I have another class. Okay?
Okay, Professor. Tomorrow you're gonna be on the tutoring section, right?
I waited for you. I waited for you.
Okay. Thank you. Bye-bye.
Bye-bye. Bye, guys. Have a nice day.
Thank you, Professor.
Sure, anytime.
Thank you. You too.